Okay, I'm going to try and demonstrate here why these videos will make you smarter than your teachers and smarter than your textbook. Okay, so hold on, all right? So first of all, the test, the worst thing you can do is just memorize a rule. Okay, so Markovnikov's rule, the hydrogen will attach to the carbon that is already bonded to the greatest number of hydrogens. So this guy has the greatest number of hydrogens. This one's only got one. So the hydrogen's going to bind to that one. That is, as you know, that is just terrible. All right, memorizing rules, you don't understand a thing. The second worst thing you can do, so that's the textbook and that's what they want in the test, fine. The second worst thing you can do is to understand that this is a more stable carbocation, and therefore that is the preferred than this one. Okay, because I don't even know if they explain that properly. These carbons stabilize it. Realistically, these hydrogens want to give electrons, so they're not going to be as positive. So this is going to be a more positive state. But they just basically say that, the ones with the more carbons, the secondary and tertiary carbons are more stable carbocations. So I think that's the higher level of explanation, but that doesn't explain how it got there. I'm not going to read this because this is my better way of explaining it. And you must know the mechanism for this. So I'll come back to it because this is obviously high level and this is as good as you get. So you actually can say that, okay, so the electron pair is being attracted to this because it's delta positive, it's delta neg. That's slow because forming carbocations is always slow. And what's to stop that from forming this carbocation instead? And so that process is slow. And then so it doesn't matter how slow it is because as soon as this forms, it's going to get taken up quickly and move to this straight away from both sides if it's forming evenly. And then the bromine, you grab the electron pair and it's positive attracted to neg, so that joins up there, and that's rather quick, of course, because there's a pos neg and everything was reasonably stable beforehand, so it was slow. And then you got your finished product, so you have to be able to write that out from memory. The question is, why did you draw this carbocation rather than this carbocation? And you're just going to say, well, that one's more stable. Okay, once it's created, it's more stable, but what caused it to be created in the first place? Okay, and that's all, you stop there. As you know, chemistry is all about positive is attracted to negative. So that's the explanation that I would give there. So my explanation is different. Now, don't use this in a test or anything. Just use this so you understand chemistry because no one explains it this way because maybe it's just too easy. Pos attracted to neg sounds rather simplistic. Okay, so this is electronegativity difference here of 0.4, and the hydrogens like to give their electrons. So if you compare these two guys here, this guy will be more negative than this guy. If you compare the two of them, the electron density will be higher here than it is here because this guy's got more hydrogens and the hydrogens like to give off their electrons. Okay, so that's the answer. Okay, so that's why this positive hydrogen is attracted to the left-hand side and not the right-hand side, and that's why you get this carbocation and not this one, although it's not 100%, okay? That's another thing to not get fooled by. It's not 100% this, it's just mostly this, so somewhere between 90 and 95% depending on the conditions. So the CH bond favours the electrons towards the carbon due to electronegativity difference. That's another way to explain it. This carbon with the most hydrogens, therefore, is the most negative, and therefore will take the positive hydrogen. It's all positive attracted to negative. That's the only real explanation, actually. None of these things are actually explanation, neither the mechanism or the statement that which carbocation is most stable, because it's got to get there in the first place. Okay, so that's why the hydrogen is attracted to the carbon with the most hydrogens. And therefore, you now have this situation. So the bromine's going to go here because obviously bromine's negative and it's just going to go straight to the carbocation. And it's on that side and not often on that side. Okay? You won't read that in a textbook, and that is that's an actual explanation. The rest, even the mechanisms, are not necessarily explanations. Sometimes they are, sometimes they're not. And they're not even, it's all theory anyway. It could be wrong. But the positive attracted to negative is the strongest and the best theory that we have. It'll trump everything else. Okay,